Okay, this week we're going to be looking at actually adding and subtracting numbers, specifically whole numbers. We will look next week when we meet, or the following week, I'm not sure the exact date, but the next class meeting we'll actually look at adding and subtracting integers as well as decimals and fractions. But today we're going to really take a look at how to add conceptually and how to subtract conceptually. We're going to also look at how to use properties of numbers to compute. So we're going to start off by looking at the numeral 147, and to that we're going to add the numeral 195. And again, anytime we're representing something conceptually, we must represent it based on our number system, which is the base 10 decimal system. So if I was to represent 147, that would be 100, 4 tens are 40, 7 ones are 7 for 147. In expanded notation, that will be one group of 100, 4 groups of 10, and 7 groups of 1. So to this amount, I want to add 100, 9 tens are 90, 5 ones are 5, for a total of 195. Again, in expanded notation, that would be one group of 100, 9 groups of 10, 5 groups of 1. I want us to take a look at 7 plus 5 because in this section we're going to begin to look at properties of numbers and how to use those to mentally compute or to make computation much easier. So I want to start off looking at the 7 plus 5, and I know that even though we're in middle school, this is going to seem a little elementary, but I definitely want you all to make sure that you focus in on how to use how these properties are being used to compute in this particular slide, because oftentimes students are able to do number talks and they can't explain why. And most times they can't explain why because they don't know how to connect their thinking to the written expression. So I want to do that at this time. Notice I have 7 plus 5. You see the conceptual representation, the 7 cubes plus the 5 cubes, and at the top the written expression will be 7 plus 5. Well, looking at 7 plus 5, and notice how I've set it up. From kindergarten on up, students should be looking at number structure based on 5s and 10s. So they begin with 5 frames, then they graduate to 10 frames, and then multiple 10 frames. And notice here I've written the number 7 where there's 5 and 2 more. So they can look at that actual representation for 7 and see that if I had 3 more I would have 10. And of course 10 is an easy number. So I need 3 more to make my 7 an easier number to work with. And then I notice that I actually have 3 a part of my 5. So looking at that number 5, I notice that I can decompose it. And in your standards, you'll see that it talks about composing and decomposing numbers. I can decompose 5 into 2 plus 3 because I know that 2 and 3 more is a total of 5. I can also write that as 3 plus 2. Amount of 3 plus 2 more will give me 5. And we know that to be the commutative property. Now, I purposely used the commutative property here because I wanted to add the 3 with the 7. And when I first started, the 7 plus the quantity 2 plus 3, my 3 was not next to my 7. So I used the commutative property to rewrite that as 7 plus the quantity of 3 plus 2. So it's important that we show each of those steps. So now I can, instead of adding 3 with 2 for 5, I can remove that 3 and add it with the 7 to make a complete 10. So instead of adding the 3 with the 2 to make 5, I use the associative property to regroup that 3 with the 7 to make the 10. So again, that was the associative property. The associative property is not just a matter of moving brackets. I want to highlight that the associative property allows you to regroup a number from one number and attach it with another. So in this case, instead of adding 3 with 2 for 5, I regrouped it, and I'm going to now add that 3 with the 7 to give me an easier number of 10. Okay? We're going to do the same thing with my 4 tens and my 9 tens. So that's the same as 4 tens plus 9 tens. Now looking at these numbers, the easier number probably would be the 9. And this is just how I'm seeing it. Of course, however you see it, you might say, oh, I want to put 6 with the 4. Again, you allow students to decompose, compose, and use properties to compute however they make sense of it. So in this case, I have 4 plus 9. I noticed that if I had one more to add with the 9, I could have a complete set of 10 tens. And then I noticed that there's one that I can decompose from 4. So the 4 tens at the top, that top row, can be rewritten as 3 plus 1 plus the 9 that I originally had. Okay, so again, I decomposed the 4 into 3 plus 1 because I knew that instead of adding a 1 with the 3, I'll need to add that 1 with the 9 to give me an easier number. So I use decomposing to decompose the number. And now I'm going to use the associative property to regroup that 1. Instead of adding that 1 with the 3, I want to add it with the 9 to give me my 10. So it makes my number much easier. So again, that was the associative property. The commutative property and the associative property is the most quickly taught properties. Because a lot of times we look at a commutative property and we tell students, oh, you just move the numbers around. If it's adding, it'll have the same quantity. In associative property, I'm just moving brackets. But no, I want to make sure that we really look at how these properties are used to help us compute, not just as a matter of moving things around. So what I want you all to do now is I want you to pause the video and take a look at class activities 3E through G. I hope you all have had an opportunity to take a look at those particular problems. I want to quickly review class activity E, and I want to review the properties and how they're being used in each problem. So the first problem, notice 7,999 plus 857 plus 1. Well, I know that 7,999 is a very hard number to work with. However, if I was to just add a 1, it will be an easy number. So I'm going to use my commutative property to move 857 plus 1. Instead of adding that 1 with the 857, I'm going to move it and add it with the 7,999 for my 8,000, easy number. Then it's easy just to add from there. The second problem, 367 plus 98 plus 2. Most times, or a lot of times, students will just add left to right. They'll add the 98 with the 367, then they'll add the 2. But that's not necessarily the best way to go in this problem because that's a lot of hard computation, and we do know with our students, when they do long computation problems, it allows for more mistakes. So we want to help them add easy numbers and cut down on the number of mistakes that they make. So instead of adding from left to right, I'm going to notice that, 98 is 2 from 100. 100 is an easy number. Let me go ahead and group the 2 with the 98 and add those two together instead of adding the 98 and the 367 together first. So that's my associative property. So in that case, I have easy numbers 367 plus 100 for 467. Something very similar, well, actually a little different in this problem, the third problem you all had, 153 plus 19 plus 7. Of course, if I'm looking at 153 plus 19, those are not going to be necessarily easy numbers to add, but I notice I have a 7, and I know that if I add that 7 with my 153, I'll have an easier number of 160, so I'll use the commutative property to move the 7 next to the 153. Then I will add or use the associative property to add that 7 with the 153 instead of the 19. So I use two properties. First the commutative property, then the associative property to actually group the 153 and the 7 together to give me my 160 plus 19, which is 179. So actually this should be two properties, commutative property as well as the associative property, because I'm not adding the 7 with the 19, I'm actually adding the 7 with the 153. And the last one, of course, we see all these decimal numbers, and a lot of times students will line all this up, take considerable amount of time to compute it, when actually they could actually use mental math and just notice, oh, 695 is 5 from $7, so let me go ahead and add those two numbers together, group those two together instead of adding from left to right, and then I'll get an even 7. I can add that easily to 7 wholes and 8900ths, which will give me my 14 and 8900ths. So again, I really wanted us to complete that activity so that we could see the importance of properties. Now you all continue on with a few other activities, which we can review next time we meet if you have any questions, but those are pretty straightforward. Okay? So now that we've kind of sidetracked a little bit with properties, turn back to our previous problem. And in our previous problem, we were able to move some things around. So now that we see we have 12 groups of 1, we have 13 groups of 10, and we have 2 groups of 100. So that will be the expanded form. Well, of course, we know that according to our base system, we cannot write 13 is not a number of groups that we can have of 10s. We only can have 0 to 9 groups of 10, 0 to 9 groups of 1. So we can decompose these numbers as we've done, and you see our picture is actually according to our number system, and we see that 12 is the same as 10 and 2 more. We also see that 13 is the same as 10 and 3 more. And the reason why we do that is because we want to be able to exchange. We know that anytime we have 10 of an amount, we can exchange for one larger. So notice that I took those 10 ones and exchanged it for one group of 10. And notice the little 1 that I've put at the top of the 4. It's very important that students see where or what that strike of 1 represents. A lot of times they think that is just 1. But in this case, it's 110, and I'm left with 2 1s, according to my picture. So now I have a total of what looks like 14 10s, which if I was to add, using the associative property, I would group the 1 and the 9, because I know those are easier to add, and that would give me my 10, plus 4 is 14 10s. Well, of course, I know that I cannot have 14 groups of 10 according to my base system. So I'm going to decompose 14 into 10 groups of 10 plus 4 groups of 10. And I know that 10 groups of 10 is the same as 1 group of 100. Notice the 1 at the top that I've put and adding on or exchanging those 10 10s for 1 group of 100. So now I have a total of 4 groups of 10. Now notice how I'm going to record this. 4 groups of 10 is the same as 40. A lot of times we move in when we're adding and students don't know why. Do not know why we do that. But that's why. Because 4 groups of 10 is the same as 40 if I was to write that up to the ones place. And then I have a total of 300s for a total of 342. Okay? So that's conceptually looking at how to add with base 10, the expanded notation, and connecting it to the traditional algorithm that we use. I want you all to take a look, to pause the video and take a look at class activity 3H. Okay? In 3H, it actually presents a problem. Let's see here, sorry. Between John and Ann, looking at subtraction. Now, we've looked at base 10 blocks. We've looked at expanded notation written version. The number line is also a very, very effective strategy for showing addition and subtraction. And you all looked at that in the activities that you did earlier on in this session. Now, with this, in trying to identify who's correct or incorrect, there's several ways to look at subtraction. The first way in using a number line is I can start at 253. I know I have 253, and from this I need to subtract 99. Well, 99 is a hard number to subtract when I know that it's easy for me to subtract 100. And if I subtract 100, I know that I've taken away 1 too many. So I go forward 1 and I end up at 154. So 253 minus 99 is the same as 154. Another way to look at this is, if I was to count up, it's important that we help students to know that subtraction can involve adding up as well. So from 99, I want to add up to 253. Well, I know that 99 is 1 from 100. And if I can get to 100, I know that I can just add 153 to get to 253. And in this case, from 99 to 253 is a total of 154 jumps. So notice the number line was used differently, but it came up with the same solution. The third way is looking at subtraction as being the difference between two numbers. So say, for instance, 253 minus 99 is the same as saying, oh, I want to find out what's the difference between 253 and 99. So in this case, the easier number is to look at the difference between 253 and 100, which I know the difference is 153. And then from 100 to 99 is another 1, so the difference is 154. So again, it's very important that we help students to see different ways of using a number line. And we know that all students will not think about this problem the same. So that for that reason, we want to make sure that we're able to connect a visual number line to their thinking. Okay. So in addition to number lines, we've also looked at the base 10 materials. Again, I'm just really connecting the base 10 to the algorithm. So of course a lot of you all are middle school teachers and students may have mastered this. However, if you have students who are still having issues with regrouping and subtracting larger numbers and so forth, I would encourage you all to utilize base 10 or some type of strategy to help them see the actual process that they're going through. So 253 is 2 hundreds, 50 or 5 tens, 3 ones for 253. Now, unlike addition, with addition we actually added more base 10 blocks to what we had. With subtraction, it's very important that students understand that they're taking from what they already have. Nothing else is being added on. So in this case, I want to subtract 9 ones and 9 tens, or a total of 99 from 253. So if I was looking at the 3 ones, I want to subtract 9 ones. Well, in order to take away, I have to have that amount, and I don't have that amount. But I know that one group of 10 is the same as 10 ones. So what I did was I exchanged one group of 10, or like one $10 bill, for 10 groups of 1, or for 10 ones. So in this case, it left me with 2 hundreds, 4 tens, and 13 ones. Notice how we must connect the written expression to the actual concrete model or pictorial. So now I have 13 ones. I need to subtract 9 ones. And notice how it was easy for me to take away those 9 ones, because I know that from 10, if I take away 9, I have 1 left over. Again, that's building number sense. So that leaves me with 4 ones. I now have 4 tens, and I want to subtract 9 tens. Well, of course, I don't have enough tens. However, I know that one group of 100, or 100, is the same as 10 tens, or 10 groups of $10. So with this, you can use money as well until students really understand the concept. So I could take $100 bill, go to the bank, exchange it for 10 $10 bills. And now I have 100 and 14 tens. So now I can say 14 tens minus 9 tens, would leave me with 5 tens. And notice I still have my one group of 100. So 253 minus 99 is 154. So we've looked at multiple ways to develop students' understanding of addition and subtraction with whole numbers. I want you all to take a look and take your time in working through class activities 3I through 3M. Hopefully you all have paused the video and worked through those activities. Please note any questions that you may have, and that we can answer during our next class session. I want to go ahead and move forward. That is the conclusion of this lesson. We have taken a look at sections 3.2 and 3.3. For homework, I want you to see the problems in the syllabus. Make a note, because previously or usually there's a comma between homework problem numbers, but instead of it being 7, 13, it's actually problems 7 through 13. So make sure you all revisit the syllabus to see what problems needs to be completed for homework, and your weekly reflection is due by 11:59 p.m. on the day that you complete this online lesson and all of your activities. Again, we want to make sure that you're able to immediately reflect on your entire experience with the lesson and activities. If there aren't any questions, which unfortunately the way that this lesson format is made, you can't ask me now, but I would encourage you to call, text, email, or post a discussion question that students may be able to address online.